Find the volume of the solid obtained by rotating the region in the first quadrant bounded by y equals 6 over x plus 1 times the quantity of 2 minus x equals 0, x equals 1, and y equals 0. This will be rotated about the y-axis with the picture provided, so you don't have to worry about trying to know what this function looks like. We're revolving around the y-axis, which pretty much then tells us that we must do shell method. If we tried disk, we'd have an issue in the very beginning with our rectangles. When I say that, I'm sorry, the beginning, what I mean is the rectangles that we would draw would have an issue in the that'd be a problem. It wouldn't work out. And so because of that, then we have to do shell. It's going to be an X. We draw a rectangle parallel. We connect them. That's the radius. How tall the rectangle is, that's the height. And the formula is to take 2 pi times the integral from a to b of the radius times the height. So what's the radius? It's the distance off the y-axis. That's called x. So what's the height? It's the distance up to the function. 6 over the quantity of x plus 1 times the quantity of 2 minus x. So we're ready to go and integrate this. What kind of limits? This thing is in x. We're going to move it from a small value of x of 0 to the largest value of x, which is 1. Okay, great. So we set it up, we multiply, and what we quickly realize is that we're looking at 6x over x plus 1 times 2 minus x, 2 pi times that quantity, and we're going from 0 to 1. That's definitely a partial fraction decomposition question. So we have to figure out how to decompose it, find the constants, split it into more than one fraction, and work out the problem from here. But this first slide is the setup of the shell method. Now let's go work with the partial fractions method. Is the degree of the denominator more than the degree of the numerator? Because we can't start partial fractions unless it is. Don't think that the degree of the denominator is x. No, it's x squared. We multiply those terms out. And so the answer to this question is yes, so we can start the method. The method starts with us factoring the denominator. Well, thankfully it's already done for us. There's something a little strange in the fact that we have a 2 minus x term instead of the normal kind of a x first then the constant, but we'll be careful, we'll go with that. So how does this break down? What are the 3 different types, and which of those are we using? The 3 different types of denominators are a linear power, a linear to the first power, a linear to a higher power than that, or an irreducible quadratic. We basically are looking at 2 linear terms that are raised to the first power. So that's going to be a simple decomposition of a over x plus 1 and b over 2 minus x. So now we're ready to go chase down what a and b are. We're going to set up this fraction, multiply by the common denominator, basically multiplying by the parts that are missing. So a gets multiplied by 2 minus x and b gets multiplied by x plus 1. In the end, you should have the old numerator of 6x. So we're using algebra to try to chase down these constants. We have the original numerator. We have this new numerator, which comes from putting the fractions together. And the idea is to pick numbers that make your denominator 0. It kills the entire term, and you only have to worry about 1 or 2 variables. Here, if we let x equal 2, it's going to kill the term that has a in it. And so this part is going to go to 0. And you'll be left with 12 is equal to 3b. Or that b is 4. Great. How about letting x equal -1. That'll kill the b term, because the b term will end up as a 0. I have to worry about b. For a, we get -6 is 3a. Positive 3 here. What does that make about a? A is -2. And we have decomposed it. We plug it back in, a over x plus 1 and b over 2 minus x. And we need to then integrate and finish this problem. Be aware of something strange that's going to happen with this term here, 2 minus x. We get it wrong if we just haphazardly integrate it. I mean, yes, it's a log, but you have to be careful. Think about the u substitution that happens. If you let u be 2 minus x, then du isn't just dx, du is the opposite of dx. So, we're integrating 4 times the integral of -1 over u du. Basically saying that in this part here, negative du is dx. Okay. So anyway, we end up with -4 times the natural log of u. -4 times the natural log of 2 minus x. And of course we already have the -2, and missing from this quantity here is the fact that we are multiplying by 2 pi. Let's go to the next slide and work it out. So we plug a 1 in, and we plug a 0 in. This guy is a 2. This guy is a 1. This guy is a 1. This guy is a 2. So we have 2 pi times the quantity of -2 log 2, -4 log 1. And then the other part has a -2 log 1 and a -4 log 2. Lots of negatives all over the place. Thankfully, though, the log of 1 is 0. 2 of our terms are gone now. And we have a -2 log 2 applying a negative plus a 4 log 2. The fact that they're both log 2's, we can exploit that. I know the coefficients don't match, but if you have -2 of them and you add on 4 of them, you're left with a +2 of them. And then we just take the 2 pi and maybe even, I don't know, pull the 2 and make it 4 pi log 2 for our final answer.